Hello guys, welcome back to MathZone African Motives. Still on our mathematics for grade 11, working on our exponents, and we shall have a continuation that is to look into the exponential equations. All right, so that is an introduction that we're going to focus on our exponential equations as we are working with our exponents. All right, so I want us to consider to say, as a basics from our mathematics grade 10, we had equations of this nature. Let's say we are being asked to solve for x, and we have got something of this nature. 3 to the exponent of x is equal to 1. All right, we had this scenario in our grade 10 whereby I talked about the condition of having a when being raised to the exponent, let's say x, and being equal to another a. This is the a, the base that we are considering, and equal to a to the exponent of y. Whenever we have this condition that these bases are the same, it is an automatic thing that therefore x must be equal to y. That will be the condition. X must be equal to what? X must be equal to 1. So meaning to say, when the bases are the same, we are saying that, take note, when the bases, we are considering the bases in this case, when the bases are the same, it follows that, all right? So it follows that the exponents are also the same. The exponents will be the same, all right? The exponents in this case will be equal. All right, that is to be the same. So this is the situation that we must consider of having same bases so that the exponents can be considered to be equal, so that the exponents can be considered to be what? To be equal. So in this question that we are given, we are asked in this case to solve for x, and we are given that 3 to the exponent of x is equal to 1. Take note, 3 to the exponent of x is equal to 1. Is it possible that we have, in simplest form, 3 to the exponent of x written in terms of this number 1 written as a number of 3 to the exponent? Is it possible? So whenever you consider the bases to be in simplest form, for a base, so you have to know this, for a base to be in simplest form, to be in its simplest form, simplest form, it must be what? To be in its simplest form, it must be a prime number. All right, I explained this in our simplification. If you still remember that, the simplest number that we can have is a prime number. It is a prime number. That is the simplest number that you can have. So 3 is the simplest number, which is fine. So you're going to consider 3 to the exponent of x. What about this one as a number 3? Because 3 is the simplest number that we have. That is the same as 3 to the exponent of a 0. Remember that any number to the exponent of 0 gives us 1. So we have this condition that I was explaining, that if these bases are the same, we've got the base of 3 here. We also have the base of 3 that are the same. It is an automatic thing that the exponents are equal. Therefore, the exponents at that condition must be equal. X must be equal to 0. So that is the condition. We have the value of x there. We have solved for x. All right, let us consider this question. Let us say we were given again to solve for x. All right, we are still on solving for x, and let's say this is given as 2 to the exponent of x is equal to the square root of 2. This is what we are given, and we are supposed to solve for x. All right, so the question is, how can we make this to be the same? 2 to the exponent of x is equal to the square root of 2. The first thing, from our laws of exponents, the square root of a half was taken from where? This was taken from 2 to the exponent of a half. Remember, the square root to the exponent of a half, if it was the cube root of 2, it means 2 to the exponent of a third. The number here inside of the root sign is the one that you write in the denominator. So this is a straightforward question. As you can see, the bases are the same, just like the previous case that we had. We have got a 2 here, which is the same as a 2 that we are having. So there's nothing to be simplified there. We just have to equate our exponents. So therefore, we are saying x must be equal to what? Must be equal to the other exponent on the other side, which is x is equal to what? X must be equal to half. All right. So it's not like our questions are going to be straightforward like what we are seeing here. Sometimes we might be given questions that we need to think along to write them in simplest form. Consider to say you are given 4 to the exponent of x, which is equal to 8, and you're asked to solve for x. If we check this number 4 and this number 8, they are not in simplest form because they are not what? They are not prime numbers. Remember I said, to be in its simplest form, it must be a prime number that you're considering there. So how can we write 4 as a prime number, 8 as a prime number? All right, the prime numbers that we are thinking about, remember we've got 2, 3, 5, 7. These are numbers that are divisible by 1 and itself. So 4 can be related in terms of 2. All right, let us write this. 4 to the exponent of, all right, sorry, that is 4 to the exponent of x is equal to 8. That was our question. So like I was saying, 4 in its simplest form can be written as a number in base of 2. Remember, 2 times 2 gives us 4. So that's 2 to the exponent of what? 2 to the exponent of 2. A prime number. So we've got 2 to the exponent of 2, but already there's an exponent which was given. This 2 to the exponent to this one is this 4. But what about this exponent 2? With this exponent x? What are we going to do with this? We have to affect our answer with that exponent x. What about 8 as a prime number? It is the same as in base of 2, the same base of 2, but to the exponent of what? This time to the exponent of 3. So this is what you do under an exam condition in case that you are not sure about your exponents, to say 2 is same as, 4 is same as 2 to the exponent of what? But as long you understand that the base that you are using is 2, but you do not know the exponent, at least know something, then you can at least be not sure about the exponent, but at least know that you are dealing with the base of 2 that is related to 4. So you can try your bases. 2 to the exponent of 2, you get what? You get a 4. So let's say the number was 16. You try up to that number. If the number was 16, you're going to try 2 to the exponent of 3. All right, we get what? We get 8, which is not 16. We move on. 2 to the exponent of 4, we get what? A 16. So that is how we can try our values. If you are not sure about this, you can simply try with your calculator to see until you get the value. So this is it, guys. All right, now we are back to our laws of exponents here. In order for us to simplify this, remember an exponent and an exponent can be combined together. We had our law, that was our law number 3 from our simplification, a to the exponent of m to the exponent of n, which gives us a to the exponent of mn. These two should be multiplied together. So that means if I have an exponent and exponent, I have to combine this to be a single term. That's 2 times x. So you're going to have 2 to the exponent of 2x is equal to 2 to the exponent of 3. The bases are the same, the 2 and the 2. So therefore, our exponents must be equal. So therefore, the exponents, that is, in this case, we are referring to 2x, it must be equal to 3. So if 2x is equal to 3, what have we formulated? An equation, which is a linear equation. So how can we solve for x? We can simply divide by 2 both sides. So this can cancel, and our x is going to be 3 over 2, which is same as what? 1.5. So it's one and the same thing. All right, so are we going to expect these typical questions forever? No. We are not going to expect these questions to be there from our grade level, from our grade 10 to be also there in our mathematics for grade 11. No. We are going to have a further approach to what we had before, still solving for the unknown value. Let us consider this. I want you to see something here. Let us consider that you are being asked to solve for x, and you have got an equation like this. 3 to the exponent of 2x minus 1 over 3 to the exponent of x is equal to 3. Okay, this is the equation that we are given, and you're asked to solve for x. All right. In our normal sense, we can think of, all right, I have got an equation. Yes, it's an exponential equation, but there's a fraction there. And if you consider the part of the base, this is 3 to the exponent of 2, 3 to the exponent of x. So the base is the same, yes, but raised to different. This is x, this is 2x. So meaning to say these are different terms that we're having there. So like I was saying, given that we've got a fraction, the best thing that we're going to think of, all right, I've got a fraction, let me cross multiply to remove what? To remove the fraction. That was the first thing that we can think of. All right, let's cross multiply and see what was going to happen. 1 times 3 to the exponent of 2x minus 1 is 3 to the exponent of 2x minus 1, which is 3, is going to multiply with this. So that will be 3 times 3 to the exponent of x. All right, I want you to see something in this type of an equation, of an exponential equation that we have here. It's another type of a question that we are having. Here we talked about the issue of separation of exponents. If we, the separation of these type of questions from the addition of exponents or a subtraction. If you're multiplying the bases that are the same, all right, I'm just going to consider, okay, let me just remove this. I'm just going to consider this. Remember, we talked about this, that if we have got a to the exponent of m and a to the exponent of m, we simply combine these together, which is also even a subtraction. A to the exponent of n times a to the exponent of minus n, it gives us a to the exponent of m minus n. If we combine this, we get m minus n. All right? So even if there's a subtraction there, we can separate this and have two terms that are multiplying, 3 to the exponent of 2x and the 3 to the exponent of minus 1. If we combine, guys, and add these, we are going to obtain the same 2x minus 1. If we add 3 to the exponent of 2x plus minus 1, because we are multiplying the base that are the same, we add the exponents. So if we add 2x plus minus 1, plus and minus, it gives us a minus. We are back to the same thing. So that is the situation or there. So this is equal to 3 times 3 to the exponent of x. As we can see, these two are not the same. They are not. They are not the same. But what is it that we are having here is that this 3 to the exponent of minus 1 is the same as it is 1 over the inverse, the reciprocal of a 3. So this is same as we've got 3 to the exponent of 2x over a 3. This 3 to the exponent of minus 1 is same as 1 over 3. So if it is 1 over 3, what does it mean? It means we are multiplying 3 to the exponent of 2x, which is this one, times this, which is times 1 over 3. So this will give us 3 to the exponent of 2x over a 3. Remember the concept of numerator times numerator, denominator times what? The denominator. And this is equal to 3 times 3 to the exponent of x. Again, we are back to another fraction. We've got another fraction there. But how can we remove this? This one we can simply multiply by 3 to remove this fraction, also multiply by 3 this side. So this can cancel. We remain with 3 to the exponent of 2x. So that's 3 to the exponent of 2x is equal to 3 and 3. These are just numbers. They can be multiplied together. 3 times 3 is 9 times 3 to the exponent of x. Okay, this is where we are. What type of an equation is this? It's an exponential equation, yes, but if we consider that this is 3 to the exponent of 2x, this is 3 to the exponent of x, and this is 3 to the exponent of 2x, we can see that we have got a disguised quadratic equation. What am I trying to say? We have got a hidden quadratic equation. We have got a quadratic equation which is hidden. How so? How so? Okay, let's consider this. In order for us to have 3 to the exponent of 2x, it means we were having this scenario. Remember, a to the exponent of m to the exponent of n like this was taken from a to the exponent of mn. A product on exponent means that there was an exponent and another exponent. So this here that we are seeing is the same as we have got 3 to the exponent of 2 to the exponent of x, which is the same as 3 to the exponent of x to the exponent of a 2. Is the same thing. It's either we write x inside or 2 outside. right? That is the same situation there. It's just one and the same thing. What are we trying to say? This here to write a to the exponent of m to the exponent of n like this, and someone writing a to the exponent of n to the exponent of n to just interchange this is just one and the same thing, which gives us a to the exponent of mn. One and the same thing. All right. Now that we understand that this is one and the same thing, which way is the best for us to write this? Which is from this here, which is the best way? This one or the second one? That is the question. Are we going to use the first scenario or are we going to use the second one? And why using the first or why using the second one? That must be your question. So each must have a reason. Each must be from a reason. So this one is the best for us to have. The reason why is that we are already having a 3 to the exponent of x here. If we check, we are having this as written 3 to the exponent of x. So it is best for us to properly see this as 3 to the exponent of x. So this is the same that we're having here, 3 to the exponent of x to the exponent of a 2, all right? Sorry, let me just use this one that I was using here. So like I said, 3 to the exponent of x to the exponent of a 2 is equal to 9 times 3 to the exponent of x. Now that we can see that we've got 3 to the exponent of x and we've got 3 to the exponent of x squared. There's a squared there. That is to show us we've got a quadratic equation. The highest exponent is a 2. So we are supposed to have the format of a quadratic equation. What is the format? Remember, one of the sides of a quadratic equation must be equal to 0. So you can transpose this to the other side, 3 to the exponent of x squared minus, if it was a positive, so the moment it jumps the equal sign, it becomes a negative, times 3 to the exponent of x is equal to what? Is equal to 0. So this is what we are having now. So how can we solve for x? There are two ways. It's either we are going to introduce another letter in place of this 3 to the exponent of x that we are seeing here. All right? We can let this to say, let k be equal to 3 to the exponent of x so that we can properly see our equation. We can properly see our quadratic equation, the one that we are used to. All right, this is what I'm trying to say. If we are to substitute here in place of this 3 to the exponent of x, we substitute with the k where there is 3 to the exponent of x. We're going to put what? A k. It means here we are going to have a k, but being raised to the exponent of 2. So it's going to be k squared minus 9. 3 to the exponent of x represents what? It represents k. So that is 9k is equal to 0. What are we seeing? A normal equation. This is what we are used to, where we can solve this k by factorizing. As k is common, we can factor out k. That's k squared divided by k. That is going to give us k minus 9k divided to k and k cancels. We remain with what? With a negative 9. This is equal to 0. So what does it mean? Remember, from the 0 concept, the product of 2 to be equal to 0, it means one of these must be equal to 0. It means it's either A must be equal to 0 or B must be equal to 0. That is the case. From the 0 concept, the product of two numbers to be equal to 0, one of these must be equal to what? Must be equal to 0. We are supposed to go back to our equations. So therefore, k must be equal to 0, or the bracket of k minus 9, this one must be equal to what? To 0. So the bracket of k minus 9 must be equal to 0. So therefore, we can solve for k in this case. The first one, we got k being equal to 0, or from this, if we transpose negative 9 to the other side of the equation, it becomes a positive. So k is equal to a positive 9. But these are not the values that we are, these are not this is not our question. The question is not asking us to find or to solve for k. No, this is not our question. The question, it was to solve here for x. This is our equation was in terms of x previously. It is us who introduced another variable. Remember here, where we said let k be equal to this. So it means we have to go back to that introduction where we said k is equal to what? 3 to the exponent of x. Remember here. So remember here we said k is equal to 3 to the exponent of x. So that means in place of this, we're going to substitute. All right, so we are going to take this to be equal to 0. So that means in this case, we're going to have 3 to the exponent of what? Of x in place of k. So it means that 3 to the exponent of x is equal to k is equal to what? 0. But k represents what? 3 to the exponent of x. So it means 3 to the exponent of x is equal to what? To a 0. Or 3 in place of k, 3 to the exponent of x. So 3 to the exponent of x is equal to what? To 9. We are now back to those normal equations that we were used to from our grade 10, the part that we talked about in the first place. Remember, this is what I introduced. Is it possible for us to have 0 written as a number 3 to the exponent of a certain number? It's impossible for us 3 raised to a certain number here and we get a 0. It's impossible. That does not even exist in mathematics. So what does it mean? It means in this case or in this situation, there is no solution. It's not applicable here. There is no solution. There is no solution. You can't write 3 to try any number that you want on your calculator. It's impossible for us to say 3 to the exponent of this number, we get a 0. If you have that number, can you write it on the comment section? Let me know. All right, that is impossible. Or we move on to this one. Is it possible 3 is a prime number, which is true? 3 is a prime number, so it's in simplest form. So we have to focus on the number which is not a prime number, which is this 9. Remember, that's what I said. So can we write 9 as this number 3, which is the smallest number, or the simplest number? Yes, it's possible. That's 3 to the exponent of 2. Remember, 3 times 3 gives us a 9. So that means we are saying the bases here are the same. We have got the base of 3 here. That is the same as the base of 3 here. So therefore, our exponents are the same. So therefore, x is going to be equal to this exponent of what? Of 2. This is what you're going to have at the end. So as we saw that on the first place, we can't write this 0 as a number of x to the as a number of 3. 3 to the exponent of what? Which is going to give us a 0. If there is a number that you can put here on the exponent that you get a 0, please let me know, guys, on the comment section. This is maths. Maybe numbers, they do change. We do not know, but that does not exist. That does not exist. All right. So this is how you can have it. So we can use the K method, or you can even solve direct. So they are typical questions. It's not like always when you see two terms, the K method is used. What am I trying to say? Let's say we want to solve for x like this one. And we are given 4 times 3 to the exponent of x plus 3 to the exponent of x is equal to 15. It's not always where we can say, let this be equal to k. Yes, we can do that. But this is a situation which is the same. These terms are the same. So we can actually factor out 3 to the exponent of x, which is the common. This is just like we've got a 1 there, isn't it? This is just like 4 times 3 to the exponent of x plus 1 times 3 to the exponent of x, which is equal to 15. So you can see that we've got a common term. It's not an issue of having a k there, because this is a common term, 3 to the exponent of x. We can factor it out. So some of the cases you can even factor out by factorization here. We can factorize 3 to the exponent of x. We remain with what here? We remain with a 4. We factor out 3 to the exponent of x. We remain with what here? A plus 1. So this is plus 1 is equal to 15. What is it that we're going to have? 3 times 4 plus 1. What is 4 plus 1? That is 5. So 3 to the exponent of x times 5 is equal to 15. What we need is to find or to solve for x. All right, sorry. We're going to divide by 5. 5 is common here. So just divide by 5 because you're multiplying. So that is it. 3 to the exponent of x is equal to 5 into 15, or 15 divided by 5. This is going to give us a 3. So as we can see already, we have a 3 and a 3. The bases are the same. So how can we write this 3 so that it remains as a 3? It must be raised to the exponent of 1. So the base of 3 are the same. So therefore, x is equal to what? X is equal to a 1. That is the condition of our question. It's not always that you're supposed to just introduce, let this k. Yes, you can do that. But sometimes consider also your questions. when it's an advantage for you to simplify direct, to solve direct. What am I trying to say? We might be given questions like this one again, solve for x. Again, we are asked to solve for x. And there we are given 2 to the exponent of x plus 1 plus 2 to the exponent of x minus 1 is equal to 5. So it's not always where this case introduced. Yes, here we can separate our terms, like I said before, that the part of addition and subtraction, these two can be resolved as 2 to the exponent of x, which is multiplying 2 to the exponent of a 1. The same thing plus here, if we separate, we're going to have 2 to the exponent of x. That was multiplying 2 to the exponent of a negative 1, so that if we combine these two, we get a negative 1, which is equal to 5. So as we can see, these are having same exponents. The exponent here, it's x, direct x, not 2x. This is x and this is x. So on this situation, there's no need for us to have those introduction of quadratic. No, this is a normal, a linear equation under these exponents, but considered as a linear because we can factor out this common term. 2 to the exponent of x can be factored out. We remain with what here? We remain with 2 to the exponent of a 1 plus here we remain with what? 2 to the exponent of minus 1. So we're going to add 2 to the exponent of minus 1, which is equal to 5. All right, so in this case, guys, you can even divide by the bracket. You can divide by 2 to the exponent of 1 plus 2 to the exponent of minus 1, 2 to the exponent of 1 plus 2 to the exponent of minus 1. This cancels here. We remain with what? 2 to the exponent of x, only there. 2 to the exponent of what? Of x, which is equal to this part. We have to simplify that part. So how are we going to simplify this? All right, here we can even use our calculator, guys, even though we are asked not to use a calculator. But this one, guys, you can just use your calculator. No one is going to know that you've used a calculator there. That's 5 over 2 to the exponent of 1, which is just 2, plus 2 to the exponent of a negative 1 like this. This is going to give us a positive 2, just a positive 2. All right, so this is going to give us a positive 2. So is it possible for us to write this 2 as a number? Already it's a number in base of 2. This is 2, this is 2. So it's to the exponent of what? To the exponent of 1. The bases are the same, so therefore the exponents must be the same. So therefore our x is going to be equal to 1. That is the situation of our question. Guys, we have to be very careful. We have to be very, very careful. So the scenarios or the situations where k is not involved, there are so many. These are not the only scenarios. There are so many. We just have to work with more questions so that we are able to work. If we are able to revise as much as we can be able to understand this. Like for an example, again, to solve for x, we are still solving for x. And this time we are given 2 to the exponent of x plus 2 plus 2 to the exponent of x minus 1 plus 2 to the exponent of x equivalent to 84. Whether they are 4, whether they are 20 terms, the idea does not change. We have to separate where there's a need for us to separate. X plus 2 on the exponent, meaning to say we can multiply this 2 to the exponent of x times 2 to the exponent of a 2. Plus, we do the same thing. There's x minus 1 there, so it means we add 2 to the exponent of x times 2 to the exponent of minus 1. Plus, this is just a single term, so it's just going to remain as it is 2 to the exponent of x, which is equal to what? 84. So as we can see, the 2 to the exponent of x is common on these terms. 2 to the exponent of x is there, 2 to x, and is the same. There's no 2x or 3x. It's just the 2 to the exponent of x as it is. So he said when that situation arrives, factor it out. Factor out that term, it's common. Here it's there, here it's there, here it's there. So you factor it, that term which is common throughout. So if we factor out 2 to the exponent of x, what do we remain with? We remain with 2 to the exponent of 2. This is 2 to the exponent of 2. Here we remain with 2 to the exponent of minus 1. Plus, if we factor out here, there is like a 1. There's a 1 there, so you're going to remain with a plus 1, not a 0, but a 1. All right, so this is what you're going to have. So you can even simplify this times. I just want to simplify this and see what you're going to have. Let us just have this as a single term. Yes, we're going to divide by that, but let us just simplify. This is 2 to the exponent of 2 plus 2 to the exponent of a negative 1. Then we move aside plus a 1 in this case. So this is going to give us 11 over a 2. All right, 2 to the exponent of minus 1. All right, so in actual sense here, this was 2 to the, my original question was a negative 2. Sorry for that. Let us just correct. This was my original question. I don't know why I wrote a negative 1. My original question, I used a 2 here on my preparation. All right, so this is supposed to be a negative 2. Let us just correct here and put a negative 2. You're gonna just try, and even if you're gonna have exact values, I do not know if you're gonna have exact values there. All right, so that was gonna give us 21 over a 4. So this is times 21 over a 4 like this, which is equivalent to 84. So like I'm saying that at this stage, we can see that this is affecting, this is multiplying. So you can divide by the bracket. We can divide by 21 over 4 both sides. We can divide by 21 over 4 both sides so that we remove this and just remain with what? 2 to the exponent of x. So thus we're going to have 2 to the exponent of x is equal to this divided to this. All right, so let's divide and see what we're going to have at the end. 84 divided to the answer that we had before, that is going to be a 16. So now we have to solve for x. We are now back to a normal exponential equation that we are used to, whereby we can make these to have the same base. 2 is a prime number, so it's in simplest form. So it's just going to remain as it is. What about 16? It's not a prime number, so we can we write it as a number in base of 2? Yes, it's possible. That's 2 to the exponent of a 4. 2 multiplies itself 4 times, it gives us a 16. The bases are the same. So what does it mean? It means that the exponents will be the same at that condition. X must be equal to what? X must be equal to 4. So therefore, in this case, X is equal to what? X is equal to 4. All right. So there are so many questions that you can consider. I want you to try as much questions. Try by all means to work out these typical questions. And some of these questions you can even avoid to work with the introduction of the K method. It's not like you can avoid that, but some of the questions are avoidable. All right, 9 to the exponent of x minus 3 to the exponent of x minus 2 is equal to 0. It's true that these are different. This is a 9, this is a 3. And 9 is not a prime number. 3 is a prime number, meaning to say 3 is in simplest form. So let's write 9 in terms of what? In terms of 3. So 9 is same as 3 to the exponent of 2x. Minus 3 to the exponent of x, all right? Minus 2 means 3 to the exponent of minus 2 there, which is equal to 0. So if we are to check, there was a situation that we had previously where we introduced decay so that we cater up the 3 to the exponent of k to say this here is same as we've got 3 to the exponent of x to the exponent of 2. Remember, I explained why and how are we supposed to write it this way. That is true. Okay, but I also want to ask this thing. We're going to use this one. Okay, well, let me ask this thing again. If we consider this thing here, if we consider to say we've got the bases that are the same, the base of 3. 3 to the exponent of x is multiplying 3 to the exponent of x. How do you simplify? Let's go back to our normal simplification. The bases are the same. What do? We add the exponents. So it's going to be 3 to the exponent of x plus x. Isn't it, guys? This is true. X plus x. And what is x plus x? This is 1 plus 1, which is going to give us 3 to the exponent of 2x. So meaning to say also 3 to the exponent of x times 3 to the exponent, it gives us 3 to the exponent of 2x. So this is another way. It's not like always this is supposed to be 3 to the exponent. Like I said, I'm going to explain that one again. No problem. But we can also use this way. What am I trying to say? If we are to expand this as this way, 3 to the exponent of x times 3 to the exponent of x, the reason is that we can be able to factorize here. Okay, let us write and see. 3 to the exponent of x times 3 to the exponent of x minus 3 to the exponent of x times 3 to the exponent of minus 2 is equal to 0. Okay. We have written in terms of 3 to the exponent of x, which is fine, which is the same as this one. So we can factor out the 3 to the exponent of x because it's common between the two terms. So here, I'm just going to take one of these. There are two of them. So I'm just going to take this one. And on this, we've got also 3 to the exponent of x here. So if we factor out the 3 to the exponent of x, which is the common term, this one, what do we remain with here? We remain with 3 to the exponent of x minus, if we factor it out here, we're going to remain with what? 3 to the exponent of minus 2 like this. This is equal to 0. We are now back to our normal, the zero concept. The product of 2 to be equal to 0, it means one of these two must be equal to 0. 3 to the exponent of x must be equal to 0, or this bracket that we are having of 3 to the exponent of x minus 3 to the exponent of minus 2, this is just same as 1 over 3 to the exponent of 2, remember, which is 1 over 9. So it's same as we've got minus 1 over 9, representing 3 to the exponent of what? 3 to the exponent of minus 2, which is equal to 0. Right? Or you can even leave it like that. Leave it like that. No problem, because I might confuse you. Minus 3 to the exponent of minus 2 is equal to, let me just leave it like that. Okay, leave it like that. Leave it like that. Okay. The first part here, is it possible for us to solve for x? It's impossible. We talked about the zero concept of this nature, where something is equated to 0. There's no way we can have 3 raised to a certain exponent to give us a 0. So the first one, it's not applicable, meaning to say there is no solution in this case. All right, there is no solution. All right, there is no solution there. All right, solution. Guys, look at the way that I'm writing here. There is no solution. All right. So if there is no solution, let's consider what? The second part. 3 to the exponent of x minus this must be equal to 0. Let us just transpose 1 to the other side, transpose this to the other side. It becomes a positive. 3 to the exponent of x is equal to 3 to the exponent of minus 2. Already the bases are the same. So it means the exponents automatically must be equal. So therefore, x is equal to minus 2. Okay, like I said, there are different ways of solving these equations. Different ways. We saw the intro here. We could have introduced the k concept, the introduction of the k. We could have done that. We could have done that on this equation, on this part here, where we had this product of these two to say, let k be equal to 3 to the exponent of x. So it means on this one, remember we said it's the same as 3 to the exponent of x squared. So it will be k squared minus this times this, meaning to say we're going to have 3 to the exponent of minus 2k, which is equal to 0. Remember, 3 to the exponent of minus 2 is same as 1 over 9. So this is same as what minus 1 over 9k is equal to 0. All right? So we can solve this equation. K is common, so we can factor out k. We remain with k. Minus 1 over 9 is equal to 0. So one of these must be equal to 0. K is equal to 0, or k minus 1 over 9 is equal to 0. So k is going to be positive 1 over 9. So from these are the values of k that we are obtaining, not x. So we have to bring back that situation. Let this be equal to 0, or this be equal to this. We are now back to this same situation. We have our same values of x, which is x is going to give us minus 2. And the first part, there's no solution. Remember, 1 over 9 is written as 3 to the exponent of minus 2. So meaning to say our x is going to be minus 2 there. So guys, these are the questions. We have to revise as much as we can.